Hello! In this lesson we are looking at midsegment theorem. Our essential question is, how are the segments that join the midpoints of a triangle side related to the triangle side? We start with definitions. Midsegment of a triangle. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. If we're looking at this triangle ABC, our midsegment is line segment DE, where D and E are the midpoints of this triangle. D is the midpoint of line segment AB, and E is the midpoint of line segment AC. Let's look at our first example using midsegments. We start by finding what our midpoints are for line EC and ED. Graphically, we can just see where the points are. However, I'm going to prove it algebraically. So I'm using the midpoint formula, so the capital M, where it's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. I'm going to plug it in to find my midpoint for line EC and also for line ED. So F is located at -3 plus -3 divided by 2. -3 plus -3 is -6, divided by 2 is -3. Then we have 4 plus -2 divided by 2. 4 plus -2 is 2, divided by 2 is 1. So our midpoint F is located at x equals -3 and y equals 1. Same thing with G, so we want to find this midpoint of the line ED. Same idea. We're going to do -3 plus 5 divided by 2. That's -3 plus 5 is 2, divided by 2 is 1. And then we've got 4 plus 4 divided by 2. 4 plus 4 is 8, divided by 2 is 4. G is located at x equals 1, y equals 4. Now that we found our midpoints, let's go ahead and find the slopes of CD and FG. I'm going to rewrite my points over here. So this was at -3 and 1, and this was at 1 and 4. Remember your slope formula, that's a lowercase m, is y2 minus y1 over x2 minus x1. So we have 4 minus a -2 over 5 minus a -3. 4 minus a -2 is 6. 5 minus a -3 is 8. 6 and 8 can be simplified to 3 over 4. Let's now find the slope of FG. Same idea, using the formula y2 minus y1 over x2 minus x1. We got 4 minus 1 over 1 minus a -3. 4 minus 1 is 3. 1 minus a -3 is 4. Notice that our slopes are the same. Because the slopes are the same, we can say that the slopes are equal. Therefore, line segment FG is parallel to CD. Let's now go ahead and find the lengths of line segment CD and line segment FG. Okay, lengths. Remember, the formula for length is the same as finding the distance, which is square root of x2 minus x1 square plus y2 minus y1 square. To find the length of CD, we've got 5 minus a -3, the whole thing squared, and we've got 4 minus a -2, the whole thing squared. When we simplify this, this is square root 100, which square root of 100 is 10. Now finding FG, and let me rewrite this so it's -3, 1, and over here it is 1 and 4. So finding the lengths, we've got 1 minus a -3 square plus 4 minus 1 square. Simplify that, you get that this is the square root of 25, which is 5. So if I look at the ratios of the length FG to CD, this is going to be 5 over 10, which reduces to 1/2. So line segment FG is half as long as line segment CD. Which brings us to our midsegment theorem. The segments connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. So we can say that line segment DE is parallel to line segment AB, and that DE, the length of DE, is 1/2 the length of AB. Using the midsegment theorem, so we're on example 2. Here we are given that line segment ST and line segment TU are midsegments of triangle PQR. Find PR and ST. So we have to find the lengths of PR and ST. PR is this length over here. Notice that the midsegment that is parallel to it is TU, and PR looks like it's bigger, so I know that it's twice the length of TU, and TU is 20, so PR is 2 times 20, which is 40. Let's look at ST. Length of ST is over here. That's much smaller than QR, so I know that ST is 1/2 the length of QR, where QR is 30, so 1/2 of 30 is 15. All right, it's your turn. I want you to answer checkpoint problem number 1 and 2. Checkpoint problem number 1 says, show that the midsegment MN is parallel to the line segment JK and is half as long as JK. So very similar to example 1. Checkpoint number 2, line segment AB and BC are midsegments of triangle XYZ. Find XZ and BC. Moving on, we are using midpoints to draw a triangle. So we are given that the midpoints of the sides of a triangle are D, 3 and 6, E, 6 and 5, and F, 5 and 3. What are the coordinates of the vertices of the triangle? So first thing is, we're given the steps here. It says plot the midpoint. So let's go ahead and plot the midpoint. D is at 3 and 6, E is at 6 and 5, and F is at 5 and 3. Create our triangle. Next step is to find the slopes of the midsegment. So I'm going to find the slope of DE, EF, and FD. Remember, slope is rise over run. So let's start with finding the slope of DE. Slope of DE is rise of 1, run of 3. That's a negative slope, so DE is negative 1/3. Slope of EF. EF is here. It's a positive slope with a rise of 2 and a run of 1. And finally, finding the slope of DF. Has a rise of 1, 2, 3, and a run of 2, and it's negative, so it's negative 3/2. We're going to use these slopes to create the lines of the triangle. Remember, you want to create lines that are parallel to the midsegment, and they have to have the same slope. So for example, if I'm looking at DE, the line parallel would go through point F, and the slope of DE is negative 1/3, so I'm going to create that negative 1/3 starting at point F. Go down 1, 1, 2, 3, and then go up 1, 1, 2, 3. And that is a negative slope of 1/3. Trying my best to go through point F. Okay, not the best right there. Okay, going to do the same thing. Over here, I want to create a line that's parallel to EF, and I know it's going to go through point D. That's where it's going to be parallel. And EF has a slope of 2, so starting at D, I'm going to go 1, 2 over 1. Here's 1 point, and then go up 1, 2 over 1. And then the last one should have a slope of negative 3/2, but all I'm really going to do is just connect those dots. And now I can figure out what my vertices are of this triangle. So this one's located at x equals 2, y equals 4. This one's located at x equals 4, y equals 8. And last one's located at x equals 8, y equals 2. So here are your answers. All right, checkpoint problem number 3 is yours. The midpoint of the sides of a triangle are D, 3 and 4, E, 5 and 8, and F, 6 and 4. What are the coordinates of the vertices of the triangle? Example number 4, we are asked to find the perimeter of a triangle. So they say that line segment JK, line segment KL, and line segment JL are midsegments of triangle MNP. How does the perimeter of triangle MNP compare to the perimeter of triangle JKL? Well, in order to find the perimeter of MNP, first we need to know the side lengths. Well, we are given the lengths of the midsegment, so we're going to use that to find the side lengths. MP is parallel to line KL, and we know that KL is 15, so MP is 2 times 15, which is 30. MN is parallel to JL. We know that JL is 12, and 2 times 12 is 24. Finally, NP is parallel to KJ, which KJ is 9, so 2 times 9 is 18. Now we can find the perimeter of triangle MNP, which is 30 plus 24 plus 18, which gives me 72. We can also find the perimeter of the smaller triangle JKL, which is 15 plus 12 plus 9, which gives me 36. So I'm comparing MNP to JKL, and we know that if I take 72 and divide it by 36, I end up with 2. So perimeter of MNP is twice the perimeter of triangle JKL. Last checkpoint problem. Line segment DE, line segment EF, and line segment DF are midsegments of triangle ABC. Find the perimeters of triangle ABC and triangle DEF. How does the perimeter of triangle DEF compare to the perimeter of triangle ABC? That's it from me. See you all later.